Question 15. The curve C has equation x squared tan y equal to 9, where y is more than 0 and less than pi over 2. Show that the derivative is equal to negative 18x over x power 4 plus 81. Okay, so just differentiation, and it's implicit differentiation, and try to rewrite into this form. Okay, so if we differentiate this, so x squared times tan y, that is a product. So we need to use the product rule. So that would be x squared times by the derivative of tan y. Tan y differentiate to sec²y, but it's not x, it's y. So y is a change we times by the derivative of y, which is dy over dx. And then plus tan y times by the derivative of x squared. So x squared just differentiate to 2x. And then 9 differentiate to 0. So the first part is done. So we just have to rearrange it into that form. So make dy over dx as a subject. I will minus 2x tan y for both sides. And then divide by x squared sec²y for both sides. And then simplify this. First, I can divide by x straight away. So that just be negative 2 tan y over x sec²y. But in the final answer, we only want it in terms of x. We don't want any y. So we need to change y in terms of x. So we know x squared tan y equal to 9. So that means tan y is equal to 9 over x squared. So we can change that. So on top, tan y, that would be 9 over x squared. And in the denominator, we have sec²y. So there's an identity we can use to change sec² into tan y. So just 1 plus tan² is equal to sec²y. So once we got this, we can change that into in terms of x. So that would be negative 2 times 9 over x squared over x times by 1 plus. We know tan y is 9 over x squared. So tan² is just 81 over x power 4. So now if we simplify this, so that will give us negative, so our times by x squared for both top and bottom. So then this will cancel out. So on top is just negative 18 over x power 3 times 1 plus 81 over x power 4. So then times them out, that would be negative 18 over x cubed plus 81 over x. So now times by x for both top and bottom. So that would be negative 18x over x cubed times x is x power 4, and 81 over x times x is just 81. Then we got the same expression. And then part B. Prove that C has a point of inflection at x equal to 4th root of 27. So for point of inflection, we need the second derivative. So I will differentiate this again. So the second derivative would be use quotient rule because it's a quotient. So square the denominator v square, and on top would be v times by du over dx, which is negative 18. And then plus minus negative 18x times by the derivative of v, which is 4x cubed. So then simplify this, expand it out, it will be negative 18x power 4. And then 81 times by negative 18, that would be negative 1,458. And then negative will make it positive. That would be positive 18 times by 4 is 72 x power 4. And then all divided by x power 4 plus 81 squared. So then 72 minus 18 is equal to 54. So 54 x power 4 minus 1458 over x power 4 plus 81 whole squared. So to prove whether a point is a point of inflection. So point of inflection is just where is a point where it's just about to change from concave to convex or convex to concave. That limiting point, we call it point of inflection. Yeah. So the whole point is, if it's a point of inflection, then the second derivative will change sign. So what we do here is just have to find a value which is a little bit smaller than 4th root of 27 and a little bit bigger than 4th root of 27. So fourth root of 27, if we change into decimal, that would be 2.279507057. So a value which is slightly bigger, we can use 2.28, and then slightly smaller, that would be 2.27. So we just have to substitute both values into the second derivative to see whether there's a sign change or not. So substitute that in. So first, I will substitute 2.28 into the second derivative. So 54 times 2.28 to the power 4 minus 1458 over 2.28 to the power 4 plus 81 all squared. So put that in the calculator. So 54 times 2.28 to the power 4 minus 1458. And then divide by 2.28 to the power 4 plus 81 to the power 2. So that is equal to 1.08 times by 10 to the power negative 4, which is more than 0. Okay. And then we substitute the other one into the second derivative. So x equal to 2.27. So 54 times 2.27 to the power 4 minus 1458 over 2.27 to the power 4 plus 81 all square. So I'm just going to change all the 2.28 into 2.27 from my calculator. So that is equal to negative 2.0896 times by 10 to the power negative 3, which is less than 0. So since second derivative change sign, therefore x equal to fourth root of 27 is a point of inflection.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.